If you want facts about the universe that will blow your brain, well, you don't have to look very far. The universe is pretty astounding. Put it this way, all the ordinary matter in the universe, the stuff that makes up you, me, and everything we can see, accounts for just 4% of its total mass. And the biggest component? A force we barely understand. In 1998, scientists discovered that 70% of the universe is made up of something we call dark energy, yet no one knows exactly what it is. As the British biologist J.B.S. Haldane once put it, the universe is not only stranger than we imagine, it is stranger than we can imagine. And with that in mind, let's dive into 15 of the most shocking, mind-blowing truths about the universe that you won't learn in school. Number 15. A cloud of alcohol. If you've ever wished for a world where clouds rain alcohol, you're in luck, sort of. Floating out in deep space, in the constellation Aquila, is an actual cloud of ethyl alcohol. But this isn't some tiny mist. It's 1,000 times bigger than our entire solar system. Unfortunately, this interstellar bar is a bit out of reach, 10,000 light-years away to be exact. Even if we could get there, the sheer scale of this cosmic cocktail would be overwhelming. Scientists say it contains enough alcohol to make 400 trillion pints of beer, more than enough to keep the entire human race partying for eternity. Space, where happy hour never ends. If only we could get there in time for the last call. Now just imagine if we could figure out how to tap into this cloud and bring it back to Earth. Well, technically it's just a dream. But as they say, a glass of something is better than a glass of nothing. Number 14. Earth's rotation. In school, we're taught that a day is exactly 24 hours long. But that's not quite true. Well, we're not kidding. In reality, Earth's rotation is slowing down, and NASA reports that a full rotation actually takes 24 hours and 2.5 milliseconds. Tiny, right? But over billions of years, those milliseconds stack up. For example, when dinosaurs roamed the planet, a day lasted only 23 hours. Go back a billion years, and you'd have even shorter days. It makes you wonder, if time is moving at this microscopic crawl, how different will our days be in the far future? Will a day eventually stretch to 25 hours? And if so, can we finally get an extra hour of sleep? Time waits for no one. But technically, Earth's rotation is slowing down, so maybe it kind of does. So schools may need to revise their curriculum and teach us that a day is actually 24 hours and 2.5 milliseconds long. Number 13. Galactic years. We all know that a year on Earth is 365 days, but have you ever wondered how long it takes for our solar system to complete a single orbit around the Milky Way? Brace yourself. One galactic year is a staggering 230 million Earth years. To put that into perspective, the last time our solar system was in this exact spot in its orbit, dinosaurs still ruled the planet. By the time we complete another full trip around the galaxy, humanity as we know it may be long gone. It's a mind-bending thought that stretches the limits of our understanding of time. Even more mind-blowing is the possibility that our galaxy itself might be rotating around something even larger. If the universe is truly infinite, what is the Milky Way orbiting? And just how long would that cosmic journey take? Time is a flat circle, or in this case, a mind-numbingly slow orbit. Number 12. Unseen objects. Despite all our technological advancements, most of the universe remains unseen. Telescopes and satellites can scan the cosmos in multiple wavelengths, radio waves, infrared, and X-rays, revealing celestial objects our eyes can't detect. But there are still massive, mysterious regions that remain invisible. One leading theory? Dark matter. Scientists estimate that around 85% of the universe's total mass is made of something we can't see or directly measure. Unlike regular matter, dark matter doesn't emit, absorb, or reflect light. It's just invisible. Yet, its gravitational effects suggest it's everywhere, shaping galaxies, bending light, and influencing the universe on a grand scale. We don't yet know what dark matter is, but if it exists, it means the visible universe, the stars, planets, and galaxies we see, is just the tip of the cosmic iceberg. The real story might be happening in the darkness. Most of the universe is missing, and honestly, that's kind of terrifying. Number 11. The age of the universe. It's easy to think of a human lifetime as long. A 100-year-old person has lived through entire generations, historical shifts, and technological revolutions. But in cosmic time, a century is barely a blink. Scientists estimate that Earth is about 4.5 billion years old, while our solar system formed around 4.6 billion years ago. But zooming out even further, the first galaxies started forming 13 billion years ago, and the entire universe itself is approximately 13.8 billion years old. This means that if the entire universe's history were condensed into a 24-hour timeline, human civilization would have appeared in the last few milliseconds. The vastness of time makes our existence seem almost insignificant. But at the same time, it's incredible that we, as conscious beings, can even ask these questions in the first place. What if we don't find or understand the answer? Number 10. Burning ice. A planet covered in burning ice sounds like something straight out of science fiction, but it's very real. If you don't believe it, well, just Google it and you'll find your answer. Meet Gliese 436b, a Neptune-sized exoplanet 33 light-years away where ice doesn't melt, even at 439 degrees Celsius or 822 degrees Fahrenheit. So, how it is even possible? How does this contradiction exist? Well, scientists believe that the intense gravity of the planet forces water into a strange high-pressure state known as Ice X. This form of ice stays solid even at extreme temperatures, creating the bizarre phenomenon of burning ice. Essentially, the planet's heat should turn everything into steam, but instead, gravity locks the ice in place. If we could stand on its surface, well, we can't. We'd see a world of fiery glaciers, a contradiction that reminds us just how weird the universe can be. Ice that won't melt, fire that won't burn, space is just out here rewriting the rule book. Number 9. Earth as a black hole. When we think of black holes, we picture collapsed stars, cosmic giants whose explosive deaths create some of the most powerful and mysterious objects in the universe. These gravity wells warp space-time so intensely that not even light can escape. But what if Earth could become one? Logically, our planet lacks the mass to turn into a black hole. Even if the sun itself collapsed, it wouldn't be dense enough to form one. However, if Earth were somehow compressed to the size of a marble, it would become so dense that it could collapse into a black hole. This bizarre theory comes from Einstein's general relativity, which suggests that any object compact enough can trigger gravitational collapse. Of course, this isn't happening anytime soon, but it's a wild thought experiment. If Earth ever shrank to that point, our planet would cease to exist as we know it, vanishing into an infinitely dense point of no return. Number 8. The size of stars. The sun is massive, so big that it makes up 99.8% of the total mass of our solar system. That means if you took all the planets, moons, asteroids, and everything else orbiting the sun, they'd still be dwarfed by our star. For perspective, about 1 million Earths could fit inside the sun. But here's the mind-blowing part. Compared to other stars, the sun is actually pretty small. Take Betelgeuse, for example, a red supergiant in the Orion constellation. If Betelgeuse replaced our sun, its outer edges would extend past Jupiter's orbit. Then there's UY Scuti, one of the largest stars we've ever discovered. It's so big that over 5 billion suns could fit inside it. These comparisons make you wonder. If the sun is just an average-sized star, How much space do the real cosmic giants take up in the universe? The sun is huge, but it's not the biggest thing. Number 7. The smells of the universe. We often imagine space as a vast, silent vacuum, but have you ever wondered what it smells like? While astronauts can't take off their helmets for a sniff test, for obvious reasons, they do get a whiff of space when they return from spacewalks. And according to them, the space smells like hot metal and seared steak. Scientists believe this scent might come from dying stars, specifically ionized particles reacting with astronauts' suits. But here's where it gets even weirder. Research from the Max Planck Institute found that the center of the Milky Way smells like raspberries. This is due to the presence of ethyl format, a compound that gives raspberries their signature scent. So space somehow smells like both barbecue and berries. If that's not bizarre, what is? Number 6. The universe temperature. The cosmic microwave background is the faint glow of heat left over from the Big Bang, dating back 13.8 billion years when the universe was just 380,000 years old. This radiation, observed by the Planck telescope, serves as a cosmic fingerprint, revealing the earliest structures that shaped galaxies and stars. The weird part? Its temperature is uniformly 2.725 degrees Celsius, above absolute zero, minus 270 degrees Celsius. Essentially the same everywhere, even in regions that, based on cosmic expansion, should never have been in contact. This paradox suggests that there simply wasn't enough time for heat to spread evenly. To resolve this, astronomers propose cosmic inflation, a theory that suggests the universe expanded faster than the speed of light in its early moments. This rapid expansion would have allowed heat to distribute evenly before stretching space to its vast size. In short, the universe cheated physics for a moment, just to make sure everything looked uniform. Number 5. It's flat. According to Einstein's theory of general relativity, the universe can take 3 shapes: open, closed, or flat. Observations from the Wilkinson Microwave Anisotropy Probe and the Planck Telescope point to one conclusion: the universe is flat. But what does that really mean? In this context, flat doesn't mean the universe is like a sheet of paper. It means that, on a cosmic scale, space follows Euclidean geometry. Light travels in straight lines, and parallel lines never meet. If the universe were curved, open or closed, light would bend, altering how distant galaxies appear. But scientists observing cosmic background radiation and distant supernovae find no evidence of curvature. A flat universe also implies that it is infinite or so vast that any curvature is imperceptible. If this holds true, the cosmos could stretch forever, beyond anything we could ever hope to observe. The universe is vast, mysterious, and apparently perfectly flat. Number 4. Galactic cannibalism. Galaxies aren't just floating peacefully in space. They collide, merge, and consume each other in an ongoing process called galactic cannibalism. Under the relentless pull of gravity, larger galaxies absorb smaller ones, increasing in size and mass over time. This isn't just theory. Astronomers using high-powered telescopes have seen telltale signs of galactic mergers, including stellar streams, tidal tails, and arcs of dust and gas. Our own Milky Way is guilty of this cosmic feast. It has already absorbed multiple smaller galaxies, and in about 4.5 billion years, it will collide with Andromeda, its neighboring spiral galaxy. While this sounds catastrophic, galactic mergers happen over millions of years, with stars rarely colliding due to the vast distances between them. However, gravity reshapes their orbits, forming new stars, black holes, and even supermassive galactic centers. In space, the big guys don't just win, they eat. Number 3. The Great Attractor. Deep in space, something enormous is pulling galaxies toward it. a mysterious gravitational force known as the Great Attractor. Located in the Centaurus constellation, this unseen mass warps the motion of entire galaxy clusters, dragging them at speeds of 600 kilometers per second, 1.3 million miles per hour, toward an unknown cosmic destination. Discovered in the 1970s, the Great Attractor's influence is undeniable, yet its exact nature remains hidden. The biggest problem? It lies in a region of the sky called the zone of avoidance, where interstellar dust and gas obscure our view, blocking direct observation. However, through indirect studies, scientists believe it is a massive cluster of galaxies and dark matter, exerting its gravitational pull on everything nearby. Even more baffling, galaxies aren't just moving toward it, they are moving away from us at an accelerating rate, thanks to dark energy. This suggests that the universe is expanding in ways we still don't fully understand. Something is pulling us toward it, but we have no idea what it is. Number 2. The universe is going to die. The universe had a beginning, but will it have an end? According to physics, yes, and scientists have several theories on how it might happen. The most likely scenario? Heat death, aka the Big Freeze. Over trillions of years, the universe will expand so much that energy becomes evenly distributed. Stars will burn out, galaxies will drift apart, and eventually, the cosmos will become a dark, frozen void. No new stars, no light, just an eternal entropic wasteland. Then there's the Big Crunch, the opposite scenario. If gravity overcomes expansion, the universe could contract back into a singularity, essentially reversing the Big Bang. This could lead to a cyclic universe, where expansion and contraction happen over and over. A more chaotic fate? The Big Rip. If dark energy continues accelerating the universe's expansion, it could eventually tear apart galaxies, stars, and even atoms, leaving behind nothing but individual subatomic particles. Number 1. White holes. A white hole is the hypothetical opposite of a black hole. Instead of pulling in matter, it expels matter and radiation, seemingly ignoring gravity. In theory, nothing can enter a white hole, only emerge from it. However, white holes face a major problem. They violate the second law of thermodynamics, which states that entropy, disorder, must always increase. By creating order instead of chaos, white holes contradict fundamental physics, making their existence highly unlikely. Some theories suggest that white holes could be the other side of black holes, where matter consumed by a black hole is expelled elsewhere in the universe. Others speculate they might exist in higher dimensions or quantum realms. For now, they remain a fascinating but unproven cosmic mystery, one of the strangest ideas in astrophysics. If you've enjoyed this video, please like, share, and subscribe. Thanks for tuning in, and we'll see you in the next one.